The Antikythera mechanism, a marvel of ancient technology and science. This video is about the Geocentric Planetarium that probably was part of the mechanism. To be honest, it's not sure by 100% if the mechanism included a planetarium. Other functionality is absolutely backed by archaeological evidence, like the calendaric calculations and also the prediction of lunar and solar eclipses. So, let's take a journey 2,200 years back in time to ancient Greece and see what evidence exists for a planetarium and how it might have been constructed.
The Sun travels through the 12 constellations of the ecliptic once a year. Just before sunrise and just after sunset, you can see which constellation it is in. The Moon travels much faster across the night sky. It takes only 27 1/3 days to pass through all the constellations. From new moon to new moon it takes 29 1/2 days. 12 lunar months last 354 days, which is 11 days shorter than a solar year. On the front of the Antikythera mechanism, a sun hand and a moon hand showed the positions of these two celestial bodies in front of the 12 constellations of the ecliptic. The sun hand additionally showed the date in the Egyptian solar calendar. Only after 19 solar years or 235 lunar months do the positions of the sun and moon in the sky coincide again. This was the basis for the Greek lunisolar calendar, which is contained on the back of the Antikythera mechanism. In addition to the Sun and Moon, the 5 planets Venus, Jupiter, Mars, Mercury and Saturn were known. In Greece, these were the gods Aphrodite, Zeus, Aris, Hermes and Kronos, who, like the moon goddess Selene and the sun god Helios, were the wanderers in the starry sky. Whether these 5 planets were also included in the Antikythera mechanism, and if so, how, cannot be said with certainty today, since the front of the mechanism is incomplete, and no yet train of such a planetarium has yet been found in the remains of the mechanism. What has been found, however, are remains of the mechanism's inscriptions, not only on the front and back of the mechanism itself, but also from the front and back covers. These inscriptions contain details of celestial events and calendaric information. At least the planet Venus, called Aphrodite in Greek, is mentioned by name here. Apparently, orbital periods are also given. Unfortunately, only parts of these inscriptions have survived. Since Aphrodite is mentioned in this inscription, and probably also the other planets, this is an indication that there was a geocentric planetarium on the front of the Antikythera mechanism. But were such planetariums known in antiquity? The best witness from that time is Cicero, who mentions 2 astronomical devices by Archimedes and 1 by Posidonius of Rhodes in his writings. The 2 devices of Archimedes were brought to Rome after the conquest of Syracuse in 212 BC. One was a celestial globe on which the constellations of the fixed starry sky were depicted. But the other device was a movable planetarium, about which Cicero writes the following.
But this kind of celestial globe, which includes the motions of the sun, moon, and the 5 heavenly bodies called planets or wandering stars, could not have been captured on that massive sphere. The admirable thing about Archimedes' invention was that he had thought out how a single rotation could contain the uneven and diverse orbits of such different movements. When Gallus moved this globe, it happened that in that brazen model, the moon followed the sun in as many revolutions as corresponded to the number of days in the sky. Thus it happened that both in the sky and on the globe, the same eclipse of the sun occurred, and the moon entered the shadow cone of the earth when the sun was on the opposite side.
Regarding this planetarium of Archimedes, it should be said that it is very probably not the Antikythera mechanism, since it was already in Rome in 212 BC, and probably no longer existed in Cicero's time in the middle of the 1st century BC. It may, however, have been a precursor of the Antikythera mechanism. The second planetarium mentioned by Cicero was built by Posidonius of Rhodes. Posidonius was about 30 years older than Cicero, but both knew each other personally, because Cicero had met him in 78 BC during his study visit to Rhodes, and became friends with him. About this planetarium he writes,
Now if someone were to bring to Scythia or Britain the celestial globe which our friend Posidonius recently made, and whose individual revolutions precisely depict the movements of the sun, the moon and the 5 planets, which can also be observed in the sky by day and by night, who in those barbarian lands would doubt that this celestial globe was made according to exact calculation.
Let's first look at what the ancient Greek cosmos looked like. For this cosmos was supposed to be what was replicated in the Antikythera mechanism. The center of the cosmos was considered to be the Earth, around which all celestial bodies revolve in spheres. On the very outside is the sphere of the fixed stars. In this model of spheres, the Sun revolves around the Earth once a year, passing in front of the 12 constellations of the ecliptic. Further in, as the first sphere above the Earth, is the sphere of the Moon. Next to the Moon, in the second sphere, runs Mercury. In the third sphere, Venus revolves around the Earth. Only then comes the sphere of the Sun. Outside the Sun, Mars comes next, followed by Jupiter and then Saturn. Since the planets moving across the sky were thought to be gods, it was assumed that they moved in perfect orbits around the Earth. However, an explanation was needed for the apparent backward movements that occurred regularly. The explanation was provided by the epicycle theory. In this theory, the movement was composed of two circular motions. A planet moves on a small circular path called an epicycle, and this upward circle moves on a larger carrier circle. Shown here is an example for Mercury and Venus. Today, of course, we know that the planets revolve around the Sun and only appear to loop around the Earth. In ancient times this could not be seen without telescopes, nor how big and how far away the Sun and the planets really are. One had to rely on observation with the naked eye and on the records of the positions of the stars and planets seen from Earth, which had been recorded since Babylonian times. Let's assume the actual orbit of the planets around the Sun, in the animation with the distance ratios to scale. Then we do not take the Sun, but the Earth as a reference point, because it was from here that the starry sky was observed. If we keep the correct distance ratios, we see that Mars and Venus in particular sometimes approach the Earth quite closely, and are far away from it beyond the Sun. If we in the next step no longer consider the real distances, because this could not be observed and measured in ancient times, then we arrive at the sphere model, if you assume that the Earth is at the center. With the actually observed positions of the planets in the sky, the geocentric sphere model shows that they mostly move from west to east, but sometimes also in opposite directions. Let's now turn to the reconstruction of the geocentric planetarium in the Antikythera mechanism. What should be taken into account? First of all, the mean solar year. It is needed for the dates in the Egyptian solar calendar, as well as a basic unit of time for the calculation of the planetary positions. For the true position of the Sun in front of the fixed stars, the mean solar year can be used as an approximation, or alternatively, the so-called solar anomaly can be taken into account, which is caused by the fact that the Earth has an elliptical orbit around the Sun, and moves faster near the Sun than far away. Viewed from Earth, it appears as if the Sun sometimes moves faster in front of the stars, and then slower half a year later, which was already known in ancient times. The mechanism for the mean solar year survived. It is the large main wheel B1 with 223 or 224 teeth, and the 4 large spokes, which is driven manually by the adjusting wheel A1. Now to the Moon. The mechanism for the Moon has also been largely preserved. The position of the Moon is essentially derived from the 254 lunar orbits in 19 solar years. The varying orbital velocity of the Moon in the anomalistic month is taken into account by an epicyclic pin and slot mechanism. I explained this in detail in a separate video on lunar orbits in the Antikythera mechanism. The lunar phases new moon, half moon and full moon could be reproduced by a crown wheel on the lunar hand. As far as planetary positions in the sky are concerned, unfortunately no gear mechanism has survived, only a gear wheel with 63 teeth, which so far cannot be clearly assigned, the mentions of planets in the mechanism's inscription, and some pillars on the main wheel, which play a role in the reconstructions by Freeth and others. The only certainty about the planetary positions to be depicted is that they must be geocentric, in accordance with the worldview of the time. In principle, however, the question arises as to whether they are sidereal, that means they refer to the position of the planets in front of the fixed stars, or whether they should be the synodic orbits in relation to the position of the Earth and the Sun, that is, when a planet is in opposition or conjunction. Micheal Wright was practically the first to build models for a geocentric planetarium in the Antikythera mechanism. He has been researching the mechanism since the 1980s, and has built several models for a possible geocentric planetarium. He uses pin and follower gears to replicate the epicyclic movements of the planets. The planetary movements are represented by concentric hands.
In 2010, James Evans, Christian C. Carman and Alan S. Thorndike published a possible reconstruction for a planetarium. That does not include concentric hands as in the other reconstructions, but instead 5 small displays, one for each of the planets known at the time. These 5 displays are arranged within the ring of fixed stars, and are comparable in size to the small indicators on the back of the mechanism. Each of the 5 planets has its own gear train. These are driven by the gear rim of the main gear B1, which here has 224 teeth. The main events of the synodic orbit are output in each case, that is, when a planet is in opposition or conjunction. This proposal is technically very easy to implement, and requires only a few gears. However, the planetary hands do not have any backward movements, and the representation with 5 separate displays does not correspond to the planetariums of the time described by Cicero, which supposedly reproduced the movements of the planets in the sky. In 2012, Carman, Thorndike, and Evans published a second proposal that now takes into account the partial retrograde motions of the planets, according to epicycle theory. They only need 4 gears per outer planet Mars, Jupiter, and Saturn, using the same pin and slot gear that has actually been preserved for the Moon. There is 1 fixed gear per planet on the central axis of B1, with 37 teeth in the case of Mars. This meshes with a gear wheel with 79 teeth, which is mounted on one of the 4 spokes of B1, on a thicker axle. This gear has a pin, as in the lunar gear. This pin engages in a slot on a gear wheel with 58 teeth, which has a smaller eccentric axis. This turns the uniform movement of the first 2 gears into an uneven epicyclic movement, which is passed on to the 4th gear with 58 teeth on the central axis, and from there to a planetary pointer. This corresponds to 37 synodic revolutions of Mars in 79 years, or 42 sidereal revolutions. The same gear is used for Jupiter and Saturn, only with different numbers of teeth. For Jupiter there are 65 synodic revolutions in 71 years, also with 2 epicyclic wheels with 58 teeth each, and for Saturn 57 synodic orbits in 59 years, which corresponds to 2 sidereal orbits. The 3 outer planets each occupy 1 spoke of the main wheel B1. The 4th spoke is shared in this proposal by the 2 inner planets Venus and Mercury, each very simply with a fixed central wheel, another wheel on the spoke, a pin on the second wheel, and an epicyclic follower hand with a slot in the center following the pin.
Also in 2012, and independently of Carman, Thorndike and Evans, Tony Freeth and Alexander Jones published a very similar proposal, also using pin and slot gearing as in the Moon, to replicate the epicyclic motions of the planets. Mercury, Venus and the true Sun are located directly on the main wheel B1, each on its own spoke. In the case of Mercury, there is a fixed central wheel with 104 teeth, which meshes with a wheel with 33 teeth, which corresponds directly to the 104 synodic revolutions in 33 years. On the top of the second wheel there is a larger disc with a pin, into which a slotted follower engages, thus replicating the epicyclic movement. This follower transmits its non-uniform movement centrally via a tube upwards to a hand. The mechanism for Venus is constructed in the same way. In the center, a fixed wheel with 50 teeth engages a movable wheel on its own spoke with 80 teeth. This reproduces a synodic orbital value of 5 to 8, which is unfortunately quite inaccurate, and leads to incorrect planetary positions after only a few orbits. On the outer wheel there is a large plate with a pin and a follower that replicate a large epicycle circle for Venus. Here too, the resulting movement is transmitted upwards to a pointer via a central tube for output. On a 3rd spoke in this model there is a mechanism for the true Sun, but I won't go into that here. Now the pillars come into play that were found in the fragments of the real main wheel. In this model they hold a plate for the outer planets. Since 3 spokes of the main wheel are already occupied for Mercury, Venus and the true Sun, the outer planets Mars, Jupiter and Saturn are located on this plate. Each of these 3 planets is replicated by 4 gears, in the same way as the preserved mechanism for the Moon. In the case of Mars, a central wheel with 37 teeth engages an outer wheel with 79 teeth. This has a pin and a large axle, and a smaller axle off-center for the 3rd wheel with 69 teeth. It is driven epicyclically by pin and slot from the 2nd wheel, and passes its uneven motion to the 4th central wheel, also with 69 teeth, for output, and this to the Mars pointer via an output tube. Similarly, for Jupiter there are 4 wheels, central with 76 teeth and outer with 83, as well as 2 epicyclic wheels with 86 teeth each. For Saturn, there are 57 teeth centrally and 59 externally, as well as 60 teeth twice. This model by Tony Freeth and Alexander Jones contains concrete suggestions as to how the planetarium could be built mechanically, or possibly was built. They take into account the preserved findings, especially the pillars on the main wheel B1. In 2018, Ioannis Diolatzis together with Gerasimos Pavlogeorgatos published a proposal for an epicyclic gear for Venus that is more accurate than Tony Freeth's 5 to 8 proposal. There is a fixed gear on the main axle with 49 teeth. This meshes with a wheel with 47 teeth mounted on one of the spokes of the main wheel B1. Firmly connected to this is a wheel with 48 teeth on the same axle. This engages with a wheel with 48 teeth on the main axle of B1. On this wheel there is a wheel with 36 teeth, which in turn engages with a wheel with 60 teeth, which is also on the spoke axle. On top of this wheel is a pin that epicycles its rotation to a pointer with a slot in the middle. Its revolution ratio of 147 by 235 equals 0.625532 is quite close to the Babylonian value for Venus of 720,151. In 2021, Tony Freeth, David Higgon, Aris, Dacanalis, Lindsay, MacDonald, Georgakoploulou and Adam Wojcik published a revised model, which attempts to account for and explain all known archaeological evidence. An important role is played by pillars, the presumed remains of which are still present on the main wheel. They carry an auxiliary plate for stabilization, as well as a large central plate, on which the gears for the outer planets Mars, Jupiter and Saturn are mounted. The gears for the two inner planets are located directly on the main wheel B1. Mercury and Venus each have 5 gears, with both planets sharing a central fixed wheel with 51 teeth. This meshes with a wheel on a spoke of the main wheel, on which the third wheel sits. This meshes with an intermediate wheel, which in turn transmits movement to the fifth wheel, on which a pin sits, which is engaged by a follower arm with a slot. The output is passed upwards centrally from the follower arm. In this reconstruction, the gears of the 3 outer planets Mars, Jupiter and Saturn are located on the central plate, which is located at the upper end of the long pillars of the main wheel B1. There are 7 gears per planet, with all 3 sharing a fixed central wheel with 56 teeth. This meshes with the second wheel, on which the third wheel is located. This in turn passes on the movement via an intermediate wheel to the fifth wheel, on which the sixth wheel is located epicyclically with pin and slot gearing, which passes on the result to the output wheel on the main axis. The calculated planetary positions are passed upwards for output via several nested tubes. In this model, concentric rings with planet symbols are used for the output instead of pointers, which is mechanically more stable than long single-sided pointers. The proposed reconstruction is quite complex, but provides a model for a complete mechanical implementation. The extensive gearing, with additional large components such as the presumed central plate, is located between the main wheel B1 and the output plate with calendar and fixed star ring. Apart from the pillars, there is no direct archaeological evidence that the Geocentric Planetarium was really constructed in this way.
Conclusion of this review. Besides presenting the basics for a possible geocentric planetarium in the Antikythera mechanism, I've shown some reconstructions of how such a planetarium might have looked like. It is by no means certain that the mechanism included a planetarium. Beside the calendaric outputs, the celestial positions of Sun and Moon, and the eclipse predictions. However, some circumstantial evidence suggests that there was a planetarium in the mechanism, and Cicero also mentioned the existence of such planetariums at the time. How this planetarium was actually constructed and how it looked like will possibly never be conclusively clarified, unless the missing parts of the planetarium are found in the vicinity of the Antikythera shipwreck. Thank you for your attention. I would be happy about positive comments and a thumbs up if you liked the video.